Hello, thank you for watching today's screencast. Sorry about that, but the bell was in my background here. My screencast today, like I mentioned in class, is going to be attached to maybe a bonus point or two. But I want to really kind of dive a little bit deeper into something we talked about today, about how when you're squaring, and I'll go back to number 2, give you a little hint here. When you're squaring a binomial, you can't just square what's inside and get this. This is not your answer. X plus 7 to the second power means, like we said in class, x plus 7 times x plus 7. Hint, hint. So that's your answer. And what problem number 3 has you do is have you prove by double distributing these two things that you get this trinomial, and then prove it further by testing x equals 3 into both of those expressions. So we did spend a ton of time on this, but I really want to make sure we understand that it's not just for the example we looked at before, but any a value plus any b value, when you square that binomial, it does not give you this. So what question 5 is saying, Mariah thinks that the following rule should always hold true. She's wrong, right? We know these do not equal. Should it? Find evidence for or against, so is she right or is she wrong, the following equivalency rule, which I told you was wrong, by substituting various values in for A and B. All right, so let's just do one. Let's just do a test. And for my test, I'm going to pick A to be 1, and I'll pick B to be 4. Just randomly pick those numbers. I was going to go with a negative number for B, but I decided to keep it simple. So let's show that this does not work for those values. Therefore, you can't say it always works. So A is 1, B is 4. Over here on this side, following your order of operations, you're going to add these first. So you get 5, and 5 squared is 25. Now the goal is to see if that is equal to when you square them individually first. So, is it equal? Let's see. 1 squared plus 4 squared. Now you're not squaring the sum, you're squaring them individually and then adding them. So this gives you 1 plus 16, and they are not equal because 25 does not equal 17. Now problem number 6 I really like, because it's one thing for us to be really good at double distributing in situations like this and this. But what about if it's all variables? Can we write an equivalent expression for A plus B in parentheses squared using the distributive property? Yeah, we can. Let's just write it out the way we know it should be. A plus B squared is equal to A plus B times A plus B. And now let's just distribute. A times A, we can do that. A squared. A times B would just be AB. B times A. Now, I want to make it the same, similar looking. B times A is the same as A times B, right? Because we know that multiplication is commutative. So I'm going to write this as A times B again. And then B times B is B squared. And then we can simplify this even more. We know that this is really a 1AB, and this is another 1AB. And they're like terms, same variables, same exponents. So 1AB plus 1AB gives me 2AB. So the expression A plus B squared is equivalent to A squared plus 2AB plus B squared. All right, See you tomorrow. Hopefully everyone has their homework done and this bonus complete.